Hey everyone, welcome back. Let us now dive into our first example to see the principle of moment and static equilibrium in action. In this example, we will analyze a traffic light weighing 100 newtons hanging from a vertical cable tied to two other cables that are fastened to a support as shown in that diagram there. The upper cables make angles of 37 degrees and 53 degrees with the horizontal. Now we have to calculate the tension in each of the three cables. To solve a problem like this, we have to identify the reaction point first, or the action point first. So looking at our diagram, this here is our action point. We have to draw the XOY plane with that point being the origin, like that. Extracting the XOY plane from that diagram, we'll have this as our 0. Now, this tension here is in that direction. This tension is in that direction, that is tension 1. This angle here is that angle there. So this here is 37 degrees. Then T2 there is here. So that is 53 degrees. Then T3 is straight downward. T3 is straight downward. So that is T3. By the way, this is the x-axis and this is the y-axis. So we have these three vectors now. This is T2. Let us identify T3 first. Now looking at our diagram there, we can easily solve for T3. We know that the weight of the light there is mg, which is given as 1.00 times 10 to the power 2 newtons. This is the same as 100 newtons. This weight here is equal to the tension T3 there. So T3 in this case is also 100 newtons. So we have the value for T3. So tension 3 is equal to 100 newtons because it is equal to the weight of the light there. Now solving for T1, we know that T1 as a component, as a vertical component in this direction. It has a vertical component in this direction. So we can label this component here as T1 Y. T2 as also a component in the vertical direction, like that. We can label this as T2Y. Then it has a component in the y direction, in the x direction I mean. We can label it T2x. Then T1 as also a component in the x direction. We can call it T1x. Now using the first condition for a body to be in equilibrium, the sum of all forces on a body must be equal to 0. This implies the sum of forces in the vertical direction should be equal to 0. Now we have T1 y going up, so we have T1 y going up. Also T2 y is going up. Okay, this must be equal to T3, which is going down. Now what is T2y? Okay, using basic trick, just a recap, this vector here as a component in y direction like this. Then if this here is the angle, that is 53, then this is our hypotenuse T2, then this is our T2y, then this is our T2x. Okay, looking at that triangle there, if we are looking for T2, we can use T2y, we can use the sine ratio. Okay, here using the sine ratio, we have that sine 53 is equal to T2, yes, that is T2y over T2, and the opposite over the hypotenuse. So T2y is the opposite, then T2 is the hypotenuse. So solving for T2y, we have T2y, so which is T2y now T2y is equal to T2 times sine 53. This is 53 sine 53. So that's how we get the opposite component. So the same applies to T1y. So substituting there, we have this will be T1, okay, T1 sine 53 plus T2 sine, sorry, I've made a mistake there. This is 37, 37, sorry, that is 37, and then this here is 53, and this must be equal to T3, but T3 is 100 newtons. So we can label this as our first equation. So this is equation 1. Also, the sum of forces in the horizontal direction must be equal to 0. The sum of forces in the horizontal direction must be equal to 0. That implies T1x is equal to T2x. Let me write that properly. The x there should be down here. Yeah, so these are the only two forces acting in the x direction. So how do we get the x components? From here, if we want to get T2x, we use the cosine ratio. It will be sine 53 is equal to T2x over the hypotenuse. Okay, so now using that and substituting there, this becomes T1 cos 37 T1 cos 37 is equal to T2 cos 53. From here, you can simplify this by dividing cos 57. Cos 37, I mean, you divide cos 37 here. Even here, you divide cos 37. Now, what are you going to have? This and this will cancel. Then we have T1 equal to, okay, you can use your calculator, please. You can use your calculator, compute. So I'm getting 0.75 36 T2. So we can label this as our second equation. Now we have T2 in the first equation and T2 in the second equation. We have T1 in the first equation and T1 in the second equation. I can say physics ends there. The remaining part is just mathematics. We have to solve the two equations simultaneously. So let us solve the two equations simultaneously. So in this case, we've made T1 the subject already. So we are just going to substitute equation 2 into equation 1. Okay. So solving equation 1 and 2 simultaneously, in this case by substitution. So let us say substituting equation 1 into 2 okay, so substituting equation 1 into equation 2, what are we going to have? Copying equation 1, then substituting for T1. So where there is T1 here, we put this. This is the value for T1. So we substitute that for T1 into equation 1. So this is what we will have here. If you compute now sine 53, we are going to have this. So there should be T2 here. There should be T2 there. Then if you compute sine 37 times 0.7536, you have this. Now we can add. Since we have the common variable T2, we can add. So when we add, we are having 1.252 1 T2 is equal to 100. equal to 100. Now I give you 2 minutes, not 2 minutes, okay? I give you 10 seconds to solve for T2. Solving for T2 here, what are you going to have? You can divide this, both sides, by 1.2521, even here 1.2521. Then the value for T2 will be, what will be the final value for T2? Okay, the final value for T2 will be, let me even highlight it. The value for T2 will be equal to 79. That will be 79.86 newtons. This is equivalent to 80. This is equivalent to 80 newtons. So that is equivalent to 80 newtons. Now you can substitute the value for T2 back into equation 2 so that you can also get T1. So substituting the value for T2 back into equation 2 here. So this is our equation 2. So where there is T2 here, we have to put this 80 or 79.86 here so that we can get the value for T1. If we do that, we have 0.7536 here. Then where there is T2 here, we've substituted the value for T2. If we compute this, we are getting 16. So the tensions in the 3 cables are T1 equal to 60 newtons, T2 equal to 80 newtons, and T3 equal to 100 newtons. Please keep on practicing. This is how you are supposed to tackle a problem like this one. Please like the video and leave me a comment if you have a question, and also invite others to subscribe to my channel. See you in the next video. Thank you.